TRS 3D radar is a multi-mode surveillance and acquisition radar especially designed for naval applications on frigates, corvettes and offshore patrol vessels. 10 radars are presently under contract for the Danish Standard Flex 300 and corvette upgrades. 5 radars have already been delivered and installed. Number 6 is undergoing its factory acceptance test. The operational role of a modern, multi-mode three-dimensional radar is to detect all categories of targets which are of interest to the ship's mission, as well as avoiding ambiguities, false alarms, and unnecessary actions of operators. Once the TRS-3D has been set up, it operates fully automatically, delivering reliable synthetic track and identification data to the Weapons Control Center for the generation of an identified air and surface target picture. The development of the TRS-3D is based on the research, design and production of the C-band radar family of Daimler-Benz Aerospace. The TRMS is a mobile, high-powered 3D sensor with a detection range of up to 200 kilometers. The system, consisting of the radar and operation shelter, has been deployed to the German Army. The TRML is a medium-range 2D radar. A command and control center is integrated within the same shelter. Its special design features enable the reliable detection of hovering helicopters. The TRML is part of the Roland Air Defense System. The TRS-C is a 2D surveillance radar, which has been produced and delivered for the German Navy ships. Daimler-Benz Aerospace was major subcontractor for the sensors and electronics of the minesweeping system HL351, the so-called Troika. In 1992, DASA received a prime contract from the German Navy for the concept definition phase of the Advanced Mine Warfare System 2000. Together with selected subcontractors, DASA developed solutions for the detection and destruction of all kinds of mines, especially sedimented mines. This contract also includes an upgrade for the remote control of the Troika system. The electronic warfare system FL-1800 provides interception of electromagnetic signals over a wide frequency range. It analyzes and classifies complex signals, identifies threats and their platforms, and recommends and carries out the most efficient countermeasures. The FL-1800 is now being installed on all modern ships of the German Navy. The Vessel Traffic System, VTS, is operating along the German North Sea coast. Precise X-band radars and data processing subsystems with powerful software and high-resolution displays provide reliable surface target tracks for the ideal utilization of waterways and risk minimization. The outstanding features of the surface target channel processing of the VTS have been incorporated into the TRS-3D. This radar rotates in azimuth and scans up to 80 degrees in elevation. The radar is remote controlled by the operator in the weapon direction system. The antenna, with its integrated IFF, is mounted on a stabilized platform driven by electrical motors which automatically correct for the ship's motion. Very low side lobes, automatic jammer avoidance, waveform agility, pulse compression and fully coherent Doppler processing ensure the specified performance of the TRS-3D under adverse ECM conditions. Circular polarization considerably improves the performance in rainy weather. The basic TRS-3D has an antenna with 16 radiation rows. An option with 32 rows is available for extended range and more accurate elevation performance. Detection of small and fast low-flying targets within sea and land clutter, as well as the classification of hovering helicopters, are challenging requirements for the TRS-3D. Selected sorties are flown to test the capabilities of the radar in a real environment. This is a Tornado aircraft maneuvering at 3,000 feet altitude and sea state 4. The radar's sophisticated signal and data processing devices generate reliable tracks, even for the flight paths with a low radial speed. The clutter is efficiently suppressed. 3D radar performance contributes to accurate 3D weapon assignment and short system reaction time. This radar display shows the tracking of 2 drones towed by an aircraft. The drones, with a small radar cross-section, are tracked at 50 foot above sea level. Early detection and stable track data support a timely threat assessment, allowing a weapon to be assigned and activated at the earliest possible instant. Tracks of the air target channel, the sea target channel, and the IFF data are correlated. The IFF challenge is automatically initiated by the data processor. The software is open architecture, written in ADA language. Tracks and identification data are transferred to the weapon direction system using a standard interface. Sensor netting with other 3D radars located either on board the ship or within a reasonable distance improves update rates, ECCM capabilities, and economical weapon engagement. The C-band family radars are developed and produced in the Sensor Systems division of Daimler-Benz Aerospace. This division is located in Ulm, a lovely city on the River Danube in the southwest of Germany. The plant is in the middle of the town, employing about 3,000 people. The annual sales being approximately 1 billion Deutschmarks. A customer-approved quality assurance system results in a superb product quality. Military requirements are verified in our environmental test laboratories. The company concentrates on future technologies such as gallium arsenide, millimeter wave technology, active arrays, and signal processing. Airborne systems, electronic warfare, ground and naval sensors are designed, developed, and produced by the comprehensive use of common resources. The System Design and Verification Tool, SDVT, has been developed by DASA. It allows real-time simulation for the optimization of different sensors and weapons. This graphics shows the interaction of a real radar against a real jammer in a simulated scenario. During operation, the TRS-3D periodically performs self-tests. In case of a failure, an alert is displayed. More than 95% of PCB failures are detected by the built-in test equipment, BITE. A touch input device allows local control of the radar for easy maintenance. The integrated product logistic concept of DASA guarantees that the stringent logistic engineering requirements are incorporated into the system design. Standardization is accomplished whenever possible. User documentation, training, spare parts selection, and in-service support assistance are tailored to customer requirements, ensuring that the system is maintained and kept viable after deployment. The TRS-3D, a powerful naval radar from Daimler-Benz Aerospace. Early in 1996, DASA was selected as the prime contractor for the sensor upgrade for the German Navy frigates. F-122. The TRS-3D-32, a new upscaled version of the TRS-3D family, will replace the 2D search radar. The upgrade program primarily encompasses the anti-air warfare capabilities of the F-122 frigates, thus improving the detection and tracking performance of the air and surface targets whilst under ECM influence and in heavy sea, land and rain clutter. Delivery is associated with the integration of the Track Management System, TMS. It interfaces and correlates both data from the TRS-3D as well as the existing search radar in order to provide reliable identification data for the Combat Direction System and better support for the anti-air warfare weapons system, for instance the RAM. Optionally, the TMS is capable of combining other sensor data, for example ESM, infrared or off-board sensors. Among the various solutions, 2 proposals were shortlisted against fierce international competition. The order was placed in favour of DARSA thanks to their lower prices, advanced performance and better operational data. The TRS-3D, tomorrow's technology on today's ships.